section 1.2, we're going to be covering over a few days, is focusing in on line segments and midpoints. And it's got an additional definition up here. When it comes to geometry, when geometry was originally created, there wasn't the same tools that we had today. There wasn't a universal measurement system. There wasn't really a whole lot other than a compass, and what they used is a straight edge. We've got a ruler that we typically use. We're on page 6. And when they were creating shapes and drawing things out, they used these to make what they call constructions. Now, we're not going to use these a whole lot, but it's still one of our key things that we need to know about. That constructions are that creation of geometry things, and they use straight edges, protractors, and compasses. Now, the main things that we're going to focus in on are coming after that, and it's this idea of working with line segments. Now, before we actually get into the bulk of today, which of these 3 items is a line segment? Say it a little louder. Bottom one. This is a line segment. How many letters do I need to name a line segment? 2. More than 2? No, exactly 2, and the 2 better be the endpoints. A, B, and then with the bar above it. That's how we name a segment. Now that's going to get more and more particular as we move through this chapter, that you have to know how many letters and you have to know what symbol to put above it. So that's going to be something that comes up continuously. So when it comes to working with our segments, one of the things we're going to talk about with them is we're going to talk about length. Now, you can measure the length of a segment using a ruler, but that's only if it's to scale. And so the only time you're ever really going to use a ruler to measure a segment is if it specifically says measure using a ruler. Otherwise, most of the time, that segment is representing something bigger or something smaller than what it's actually drawn in as. So because of the fact that we do that, we draw these segments that represent something bigger or something smaller, one of the things we have to be able to do is we have to have notation and talk about what if they're the same length. Line segments that have the same length are known as congruent segments. Specifically, the word congruent means same measure. Now, for segments to be congruent, they will be referenced that way visually in a diagram, or they can show that they have equal lengths, or there's an actual symbol for congruent. And these are 3 different notations that we're going to use actually a lot in here. Visually, if these 2 segments are the same length, they put what are known as tick marks on them, which is these little hashes that go on them, just to indicate that these are the same length. If there are numerous segments in the picture that are congruent, if they're all the same exact length, they'll all have a single tick mark. But if there's different sets where like multiple of them are congruent, but not all congruent to each other, for example, think about a rectangle. They'll do a single tick mark for one set, and then they'll increase the number of tick marks to indicate the other ones are also congruent, but not all the same. So these 2 are the same, these 2 are the same. Now, I'm not worried that you know that they're called tick marks. You're going to hear me reference tick marks a lot, so you will hear the word a lot. But the key thing is that it's got those little dashes that are the same. Lengths are equal and segments are congruent uses the names of a segment. For example, here we have A, B, and C, D. Now, when it comes to notationally, we've talked about this notation, and this notation for things that have two letters. Line, ray, segment. And the thing you have to know about this is these are their names. Why am I emphasizing that? Because if I want to talk about a segment's name and a segment's length, I do a slight tweak on how I write it. A segment's length does not have the bar above it. It has the same two letters, no bar. So if these two are the same, I can say AB is equal to CD. Remember, you have to use capital letters. But if I talk about lengths being equal, there's no bar. Congruent, on the other hand, then I'm talking about the names of them. I'm saying a feature of them. Segments being congruent does have the bar above them. And the congruent symbol looks like an equal sign with a squiggle above it. That means congruent. That means having the same measure. When you're writing that they are congruent, you need the bar on both of them. When you're writing they are equal, there's no bar on either of them. So, one of the things that we're going to have to be able to do is we're going to have to be able to just simply identify segments as congruent. Yes, Nate?
How are equal and congruent different? Aren't they the same thing?
Essentially, yes.
Then what's the difference? What's the point of being different?
It has to do with the fact, and we're going to get into this more in chapter 2. When we are told that something is congruent, or that it has the same measure, in other words, we have different things that we can do with it, different properties, than an equal sign. It comes with the fact that congruent, for example, you can do congruent with shapes too, and unlike, but you can't say shapes are equal. It really just comes down to what you can do with equal signs versus what you can do with congruent symbols, and how that affects what we're going to do later. For the most part, they mean the same thing when it comes to segments. Okay, so one of the things we're going to do is we're going to identify congruent segments in diagrams. When you're given a diagram, there's two things you're looking for to identify congruence. One option is tick marks. The other option is it might give you the actual measurement. This first one, do you notice that any are the same? Do you notice that you had a 2 foot and a 2 foot segment there? So those ones are congruent. This segment, its name is TS, and if I'm writing that it's congruent, I put the bar above it, the equal sign with the squiggle, and the one it's congruent to is TU with the bar above it. And if I want, I can put tick marks. I don't have to put the tick marks. The tick marks are more there because we don't always know what the measurement is. This one we do know what they were. Okay, so that's one set. There's another set that's congruent here, right? What's this one's name? SW, and it's congruent to UW. Beautiful. that's all the sets in that one. And if I wanted tick marks on this one too, I would just make sure they're double tick marks because I already used the singles. Okay, congruencies over here. This one's actually using tick marks. Let's say I start with AB. AB is a single tick mark. AB is congruent to which one? AG. Do you notice that there's another one though that has a single tick mark on it? DE. So you can do extended congruent statements if there's more than just two that are congruent. We could go on forever if there were an infinite number of them. Those ones are congruent. I notice there's double tick marks and triple tick marks. Let's get those ones as well. Double tick marks. CD is congruent to FE. I heard someone say. Last but not least, last set is GF and BC. If I do the congruent symbol, do I have to have the bar? Yes. Okay, so recognizing congruence is going to be helpful as we go forward, especially once we get into some of the later chapters. The other thing, and probably the bigger thing that we're talking about today, though, is this idea of working with collinear points that are either on a line or on a segment, or on an array. They can be on an array too. And talking about their relationship to one another. What does collinear mean again? They share a line. They're on the same line. So for example, here we have collinear points A, point B, and point C. When you're talking about collinear points, just referencing something I saw in the quiz, and yes, I plan to show you your quiz today. You can either write point A, point B, point C, or you can write points A, comma, B, comma. Technically, you should write an and, but you don't have to. I'm not overly picky. And C, otherwise, commas are only used to separate answers. They don't go in the middle of things. When they're collinear, we don't draw a line above them or anything. We just talk about the points. Anyway, if there are 3 points that are on a line, it is possible you're going to have one of the points being between the others. Now, between is a word you've probably heard before. It's not one that's overly shocking. The reason I emphasize the word between in math class, though, is because between in math class and between in other situations are not always the exact same thing. Because if I were to say, okay, who are the people that are between me and Jackson, for example? Would you probably say, like, Cam's technically between us? Yeah. Darnell? Yeah. Haley? Sure. Piper? Yeah. But in math, that's not how it works. In math, for things to be between, they must be collinear. They have to be on the same line. So between me and Jackson, when I stand right here, is Olivia, Ava, and Aria only. Because if you were to draw a line between me and Jackson, those 3 would be the only 3 people we would go through. So this is between. B is between here. But on this one, E is not technically between. Between has to be on the same line. And that leads us to some math that we can do when you have collinear points with one point between on a segment. It leads us to what is known as the segment addition postulate. Now, the word postulate is one you probably haven't heard a whole lot before, if ever. Postulate, we're going to emphasize it a little bit more when we get to chapter 2, but postulate just means something that we know is guaranteed to be true. It's kind of like a theorem, but theorems someone had to prove at one point. Postulates are just existed. We just agree that they exist. And the segment addition postulate states that if a point, such as B, is between A and C, then AB plus BC equals AC. So if I have this segment, that segment is AC, and between A and C is some point B. If I have a picture like that, then, we might want to grab some highlighters. You don't have to have highlighters, but if you like highlighters, they wouldn't hurt today. I would have 3 different colors. I've got some up here if you need them. If I have that situation where I have a segment that's got 3 points on it, one of them being between, then this equation that it has here is true. AB, that's the length from here to here, plus BC, that's the length from here to here, is equal to the length of AC. That's the full length across. And this is the equation they give me directly off of that postulate sheet. That's the green part, and this is the blue part. You'll often hear me reference this as a part of a segment plus the other part of a segment makes the full segment. Part plus part equals whole. Now, just a couple things to reference on this. Do you notice that in the equation, there's no bars above things? No bar is the length of the segment. With the bar is the segment's name. Without the bar is the segment's length. If you want to use an equal sign, no bar. Now, for some of you, this initial part is probably going to be very obvious. It's when it starts getting variables involved that starts to get people to trip up. Okay, find the length of the indicated segment. Indicated segment is DF. D is here, F is here. I want that. According to my segment addition postulate, since I know the 2 parts of that segment, I can add them together to get the full thing. In other words, segment addition postulate says that DE plus EF put together makes the full thing. That's what the postulate tells me, is it gives me this equation because E is between. That being said, we know them as numbers. DE is 23. EF is 35. What is 23 plus 35? 58. So DF is equal to 58. And you can leave it as 58 equals DF. I just don't prefer to. I flip it around. First one seem easy enough? Add up two numbers to make the big one. Same idea works on this one. Just pay attention to what it's asking about. This one's asking you to find GH. That's from here to here. Now in this one, we were just able to add the two numbers together. Is adding 36 and 21 going to give me that smaller part? The equation that the segment addition postulate gives me, because G is in the middle, says that FG added to GH will give me the full length from F to H. So, GH is the one I want. FG I know. That's that piece. S21. FH, one of the things you're going to see notationally is oftentimes when it comes to big segments that have a bunch of points on them, they can't draw them directly on the picture. You'll see them off to the side like this, where they indicate, hey, that's that full length. So FH was 36. And if I have an equation like this, and I want to get GH alone, how do I move the 21? Subtract it. I already heard someone say it earlier, and you are 100% correct. I always write it out though, just to make sure we're all on the same page. 36 minus 21. You know there's calculators up here, right? You can grab one if you need one. We might need them for our coming problems. $36 minus 21, 15. And that's what the question was asking for. Sometimes they're going to be just numbers. More often than not, variables and expressions are going to be involved. So, I've got two more examples. They look very similar, but they're not exactly the same. So, C says find the value of x. Do you see that there's 3 points on one segment? Yes? No? Maybe? Do you see 3 points on the segment? Which one's between? S. S is separating the two parts. So, I got a part here. I got a part here. So my segment addition postulate, the actual formula says the part and the part together. My first part was RS, the second part was ST. Add those two together and I get the big one. What's the big one's name? RT. What's the length of RS? X minus 5. All I'm going to do here is replace in my formula that the postulate gives me. I'm going to replace with the measurements I know. It's called substitution. That's going to be important in chapter 2. Okay, do I know ST's length? What is it? 9. Do I know RT's length? Maybe not as a number, but as an expression?
Yeah.
They told me RT was what? 2x minus 7. They did it on the outside because they couldn't draw it on the picture easily. But that is 2x minus 7. The expression, or the question says to solve for x. Equal signs right here. Can I simplify that side at all? Yeah, what goes together? -5 plus 9. Put them together. 4. A positive 4. X plus 4 equals 2x minus 7. Oh, I forgot to ask. Could I simplify 2x minus 7? No, they're not like terms. They don't simplify. Remember, combine like terms on each side first, and then move things across. If x is in two places, not on the same side of the equal sign, I do their opposites. They're both positive. So I'm going to have to subtract. Do you want to subtract the x or the 2x? Generally the smaller one. Subtract x. Cancels out on this side. I'm left with 4 equals 2x minus x. X. Still minus 7. How do I get x alone? Add 7. Cancels out there. 4 plus 7 is 11. 11 is equal to x, or x is equal to 11. Is that what the question asked me to solve for? Yes, find the value of x. I asked that because sometimes it's going to ask for something else. Our final problem also has 3 points on the same segment. S is between. So, the expression I get, part plus part equals whole. What's one of the parts' names? RS. The other part's name is? ST. That's over here. And the whole part's name, or the whole thing's name, I should say, not the whole part. RT. RS's length, whether it be a number or an expression, is x minus 4. ST's length is x minus 5. Equal to full length, RT's length, 15. Is the part that's on the outside, referencing going all the way across, 15. Simplify first, then solve. 15 doesn't simplify, that one's easy. When simplifying, I want to put my x's together. Do I subtract to move them if they're on the same side? Do I undo things? No, I do exactly what they said. X plus x. 2 x's. Same thing with the numbers. -4 and -5 put together. It's a -9. And we solve. Do we get rid of the 2 or the 9 first? 9 by adding 9. 2x equals 24. How do I get rid of the 2? Divide. Divide by 2. X equals 12. You got a calculator for the easy math. Easy math is the wrong phrase. For the numerical math, I don't know why I said easy. Double check, is that what it asked you to solve for? No, it said find RS. Now when it says find RS, that doesn't mean, okay, it's right there. No, it means tell me what RS is as a single number. RS is equal to what number? RS was equal to x minus 4. We can't leave it like that, but we know what x is now, right? RS, which was equal to x minus 4, is now equal to 12 minus 4. What's 12 minus 4? 8. RS is equal to 8. Sometimes you might have to plug it back in. You might have to substitute the number back in for the variable to solve. How are we feeling about segment addition postulate? Is it okay at least?